So question 53 and 54, the directions of this one is very important because they're asking you to find the derivative of f of x, but if you see that the f of x is equal to the integral. In order to be able to do this, I want to go back and revisit the fundamental theorem of calculus before we start this question. So we'll go ahead and start with the fundamental theorem of calculus, which goes ahead and says that the area of the function is the antiderivative. Now the conditions that we have to have around here, f must be continuous on the interval from a to b, and it must be differentiable over the interval. Now, if I want to go ahead and take dx of both sides of this, then the derivative of the area function is equal to the derivative with respect to x from x to a of f of t dt is just equal to f of x. In other words, this means that the derivative of the integral of f is f. Now, it's important to note that this upper limit must be your variable. If for any reason a and x were reversed, you would have to change them and multiply by that negative to make this theorem work. Now, keeping this up here, let's go back and look at the original question. So this is almost in the form that we need, but we will go ahead and start by taking d dx, or the derivative of both sides. And when I have that, now I'm left with the derivative of x is equal to d dx of the integral of the ln of x to pi of cosine e to the t dt. Now, when we were talking about the fundamental theorem before, our upper limit was our variable, but it's not x, and our upper limit ln of x is differentiable. So because of that, we need to go ahead and use the chain rule. So we're going to go ahead and let u equal the ln of x. So u prime, or the derivative of u, is equal to 1 over. So let's go ahead and rewrite everything. So now I know that f prime of x is equal to d dx of the integral from u to pi of cosine e to the t dt. But then we need to multiply all of this times u prime. So remember, what we're doing with this is we're just going ahead and taking the derivative of the inside and then the derivative of the outside with the chain rule. So remember what we said before with the fundamental theorem of calculus, that all of this, the derivative of the integral of the function is just the function itself. So we now have that f prime of x is the function itself with respect to x. So now this becomes the cosine of e to the u, and that is because we are replacing the t with our variable of our upper limit times 1 over x, and again that is because u prime is equal to 1 over x. So all of this then I need to substitute back in for u, which gives me the cosine of e. U is equal to the ln of x times 1 over x. And this goes back to the special properties of logs. If you ever have a to the log base a of x, it just equals x itself. So therefore, all of this is just the cosine of x all over x.